Since the beginning of time, humans have always been skeptics, left to ponder and consider some of life's biggest questions, like why are we here, what got us here, and what is here. Philosophers were probably the first ones to seriously consider such questions. Many of these people focused on astrology, and by doing such were directed to the question of what is here. There is no true founder or creator of the term Earth, but it seemed to be derived from the English and German words for ground, which were Eartha and Erde respectively. During these early years, when we were still trying to figure out what this giant massive land that we were residing on, it was initially thought that Earth was flat. Reasoning for this rooting to the fact that without satellite technology and scanners, the Earth really feels and looks flat to the naked eye. Such thought provoked fear in many ancient travelers who were too afraid to travel at sea in fear of falling off the edge of the world. As time went on though, it wasn't long before most of the modern world believed that the Earth was indeed round and spherical. With our somewhat recent conception of the spherical Earth, there are still those who are, as we mentioned before, skeptics. These skeptics believe in what some choose to call the hollow Earth theory. This theory exists under the premise that since nobody is able to prove entirely with video or photo evidence what is at the center of the Earth, there must be nothing there. These skeptics believe that the center of the Earth is either a sustainable utopia of long-gone sentient beings, or just a hollow chasm with nothing inside. As fun as it may be to believe such lore, these claims are entirely false and disregarded by most of the scientific community. But thinking of the vast civilizations and fictional utopias that would be present in such a planet had me wondering, what if there was a planet like this? What if our planet was actually hollow? One major consideration would be that the gravity on such a planet. I'm sure we all have heard that the gravity is a force that keeps us grounded here on Earth, but with Earth losing so much mass due to its hollowness, how badly could our gravity be thrown off? To begin with, I made a few key assumptions. One could possibly say some bold assumptions. Anyways, I assumed the Earth had a consistent density throughout and placed the average density value of the Earth at around 5,515.3 kilograms per meter cubed, which is fairly accurate. I then assumed that the Earth would be strong enough to support this from caving in due to the presence of strong, compression-resistant materials scattered amongst the crust. Now, with all these in mind, we had to decide where the Earth would begin being hollow at. My major consideration for deciding this point was to figure out where the deepest parts of the ocean were. A little bit of research led me to the deepest known part of the ocean, Challenger Deep, which is nearly 11,000 meters deep. I played it safe and cut it off around 12,000 meters for good measure. Subtracting this value from the radius of Earth would place us at a radius of the hollow section being about 6,366,100 meters. Using the formula for volume of a sphere and plugging in values, we can then multiply the solution by the density to find that we lose about 5.96 times 10 to the 24th kilograms of mass. This means that the remaining mass on Earth is left at a value of 1.2 times 10 to the 22nd kilograms. Though this value seems large upon a first glance, it is actually small enough that when plugged into the equation to determine acceleration due to gravity of a planet, our gravity drops from a solid 9.8 meters per second to a minuscule 0.01968 meters per second squared. To put such a gravitational acceleration in perspective, the acceleration due to gravity on the Moon is about 1.62 meters per second squared, over 80 times greater than the gravity on our newly proposed Earth. Think of how weightless astronauts seemed on the Moon during the Apollo missions. They would be over 80 times more weightless than they were back then on our proposed Earth. A simple hop could launch someone so much higher than ever before, and that's assuming you would even stay grounded on such a planet to perform a jump. Due to such low gravity, astronauts on the original Apollo missions needed specialized heavy boots to make sure they wouldn't float away. These same boots would need to be up to 80 times as heavy as they were on the Moon missions in order for people to stay on the Earth. Not to mention, the average mass of a man is 70 kilograms. With our calculated acceleration due to gravity, the same person would weigh less than 1.5 pounds. One huge problem that a hollow Earth with such a small gravity would face is that it cannot hold onto its own atmosphere. For example, the small not-so-planet of Pluto has a gravity of 0.62 meters per second squared. This gravity, still greater than a hollow Earth gravity, cannot pull enough to hold an atmosphere. There's a chance that with such a weak gravity, the Earth wouldn't be able to support life nor hold many of the creations that we as man have made for this Earth. With this all being said, what would the inside of the Earth look like in a hypothetical hollow Earth scenario? For the sake of the question and scenario, we are going to assume that you as an observer can enter the center of the Earth as you choose without digging or swimming down. Once in the center, the gravity of the Earth should cancel out since it is equally pushing on you in all directions. You would be at a state of complete equilibrium, floating in the complete darkness and nothingness that is the center. For this to work just right, the Earth must be completely uniform throughout and not rotate at all. Any small imperfection can cause the forces to not cancel and therefore not allow the body to be suspended in the center. Looking back to the gravitational change of the Earth, I wonder what would happen to the gravitational pull of the Moon. One major change would be the relationship of the Earth and Moon. Assuming the Moon's gravity remains its usual value, the Moon should pull on the Earth more than the Earth does on it. This pull will eventually lead to the Earth falling into orbit around the Moon, thus switching the iconic roles of these two masses. With the Earth now orbiting the Moon, would it still be considered a planet? According to the criteria of being a planet, there are three major requirements to be fulfilled. First, the mass must be in orbit about a sun. This is still true. Next, the mass must also make itself round. I'm not sure if the newly calculated gravity fulfills this, but we're going to make some bold assumptions here that it does. Lastly, we have one questionable criterion mark. The body must have cleared its neighborhood in order to be a planet. This single requirement was the major reasoning for the controversial denouncing of Pluto as a planet. For a planet's neighborhood to be cleared, it means that the mass must continue about its orbit while either consuming or throwing out surrounding rocks and debris along the way. The very fact that gravity on Earth is so small at this point and that it is now in orbit with the Moon means that it doesn't necessarily fulfill the final criteria to be a planet. I would go as far as to say that the Moon is more planet-like than the Earth now. And at last we reach the final consensus on a hypothetical hollow Earth. For this to exist, we contort many of the definitions and explanations of the way Earth is said to work, and after all the math and all the research, we have reached one last conclusion. A hollow Earth would not be able to be a planet and would have such a weak gravitational field that no atmosphere or life could exist. But hey, don't take my word for this too much. At the end of the day, these are just some bold assumptions. See you next week, and thanks for watching.